All right, a lot of you have been turning in your worksheets for 15-1, and I've been sending them back. You just have a few things that I need you to learn. Overall, your assignments are looking really, really good. I appreciate your effort. But let me go over your ion dot structures and your ion electron configurations. That seems to be the main area where we are struggling. Now remember, ions mean that your atom is going to gain or lose electrons. You had aluminum as one of your dot structures. You did great. Dot structures show dots for the number of valence electrons you have, and the number of valence electrons are determined by the group that you're in. Aluminum's in group 3A, so it has 3 dots. Now, aluminum, we also know, is in the 3+ column, which means it wants to lose 3 valence electrons. And well, remember, the dots represent valence electrons, so if it loses 3 valence electrons, it should lose 3 dots. So aluminum would have no dots and a 3+ charge. Now, a few people are forgetting about the 3+ charge, so we need to be careful with that. Make sure, if you're showing me an ion, that you're representing its charge properly. Now, nonmetals, like your nitrogen on your worksheet, has 5 valence electrons because it's in group 5A. It also is in the 3- column, which means it wants to gain 3 valence electrons. So if it's going to gain 3 valence electrons, it has to gain 3 dots, since dots represent valence electrons. So if we started with 5, and now we're gaining 3, we're now going to have a total of 8. But once again, it's an ion. You have to show its charge. All right. Now, if we were to look at these electron configurations, if we look at aluminum, that would be 1s2, 2s2, 2p6, 3s2, and then 3p1. Now remember, aluminum wants to lose 3. So what's going to happen? Well, these right here are your valence electrons. It wants to lose 3. So those 3 are going to disappear. Those are the ones that are lost, which means this is your aluminum 3+. 1s2, 2s2, 2p6. Notice it is now full. That's most stable. Okay. Nitrogen does the same thing. Your nitrogen atom would be a 1s2, 2s2, 2p3. But remember, it wants to gain 3 valence electrons. Okay. So when it gains 3 valence electrons, they go in the outermost shell. So this becomes 1s2, 2s2, 2p6. So you gained 3 electrons. Also, this one is full, completely full, which makes it more stable. Both of these are similar to neon. Remember, neon's a noble gas, which is in our most stable group. They're inert, they don't react because they already have enough electrons. Now, the only tricky one is when you get to your transition metals, then you have to figure out their ion configuration. So let's go with Mn. Now, with all of your transition metals, you can use the shortcut. You can't always use a shortcut with the others, but with this one you can. So I'm going to do the shortcut. That's going to be Ar, 4s2, 3d5. Now, they'll tell you what the common ion is because it's really hard to predict which ion it's going to form since it can form more than one. So they'll say, what is the electron configuration for the 2+ ion? Well, the first thing you have to remember is what the 2+ means. The 2+ means it wants to lose 2 valence electrons. Right? Or 2 electrons in general, they'll always start from your valence electrons. So if it wants to lose 2, these right here are your valence electrons. 4 is your highest level. That makes it the outermost level. So when Mn loses 2, those are the 2 that it's going to lose, which means these are gone. And what's left? 3d5. Okay. Now, again, Mn can have other charges besides +2. If it loses any more electrons, they will come out of the D level. All right. Hopefully that will help you to make your corrections. When you've made your corrections, just resubmit your paper, and I'll take a look at it.